Zoot zoot. Number 2, a college prof suspects that students at the high school, his school, excuse me, mine said high school. I'm like, professor, what? Are getting less than 8 hours of sleep a night. Raise your hand in here if you get less than 8 hours a night. Yeah, welcome to the club. It gets worse. To his belief, the professor asked a random sample of 28 students. How much sleep did you get last night? Here's the data in the hours. Does the data provide convincing evidence in support of the suspicion? They tell us that we're going to use an alpha of 0.05. So our assumption here, when we do our test of significance, and again, since we're doing sample means, we're using a t-test. We don't know the standard deviation of the population. So my HO is that the average sleep is 8 hours. That's what we assume to be true about students. And my alternative, of course, is the suspicion that that average is actually less than 8. And this is where our mean, mu, is the true mean number of hours of sleep students get. Then we move into our planning. We will perform a 1 sample t-test for mu at alpha equals 0.05, and they actually told us this time. So that was kind of nice. We have a random sample of 28 students, according to the professor. That's a great question, because they probably wanted you to perform what's coming up. Let's talk about the independence first, because then we can have space for the showing that it's normal. So let's see. They took 28 students. We assume that there are more than 280 students who sleep. So the population is at least 10 times the sample. And this shows, of course, that they're independent. Since our sample is less than 30, it's a 3, Mara. Yep, the CLT does not apply. We will use a histogram to check for normality.
We can assume.
You probably could, Aaron. All right, so if we look at a histogram, I'm going to go by 2s for sleep. Did anybody get more than 12 hours of sleep in this thing?
No, 11.
11, okay, good.
Who goes around
Alright.
16?
All right, so now if we look at, there was a, let's go by 2s here as well. 2, 4, 6, 8, 10, and 12 hours of sleep. So these are hours of sleep across the bottom. On the left side, I ran out of room, it's frequency. If I do bars of what's happening from 2 to 4 hours, there were two people. Does that look right? Remember that the number 4 is the beginning, and then up to, but not including 6. Or 4 in that case, I guess. How about between 4 and 6? So not 6, but up to 6. So there's 2 people here. Is that 4 people?
Yeah,
4? And I, again, like to put my numbers on the top of these histogram bins because it helps me. How many people were between 6 and 8? So not including 8, but up to 8. 1, 2, 3, 4, 6, 13? Oh, crud. Okay, so I went past my 12, sorry. Going based on your numbers here, so 13. Between 8 and 10. 1, 2. I got 7. Did you guys get 7? Hopefully I'll be right here. I'll count these up at the end. And then 10 to 12. 2.
yeah.
So let's see. We had 28, right? 6, 21. What the? All right. So we have 28 people. If we look at this histogram, what do you think?
It's
It looks approximately normal, doesn't it? I mean, there's not really any skewness. There's no outliers, really. So, from our histogram, we see that our data is approximately normal. So on the AP exam, you're always going to go with the 4 things, and you're always going to say them whether or not you know what's going on or not. Okay? What tests are you doing? Random sample, normal, and independent. Say them all. All right, next, we do our math. So in order to do our math, we have our one variable statistics. And our one variable statistics, our x bar is equal to 6.643. Our standard deviation from our sample is 1.981. And our degrees of freedom is equal to 27. So when we find our t-value, we have 6.643 minus the 8 all over 1.981 divided by the square root of 28. This gives us a t-value of negative 3.625. Because there's 28 in the sample. So we're looking for the probability that our t is less than negative 3.625, which turns out to be 0.0006, which is ridiculously small.
I have a question.
Okay, so our mean of, what was our mean? 6.643. This is the conclusion. Would occur if the true mean was 8. Only 0.06%. We reject the null hypothesis and conclude that the mean hours of sleep for these students in the professor's schools is less than 8 hours. He does. This one's a little bit different. In this particular example, what you'll notice is there's not a table anymore with data in it. This is actually a computer printout. That's one of the things that you're required to know how to do is to read a table from a computer printout. And so here, children's game Don't Break the Ice